Hello friends, this is solved question paper of nuclear and particle physics DAC paper 1 of 2024 Dibrugarh University. Right, 6th semester, okay, CBCS. So before we start, please do subscribe the channel, hit the thumbs up button, also share it to friends, inspire me to create new contents for you and help me to grow my channel. And then if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. Here you see, choose the correct option from the following. This is question number 1. The radii of two nuclei with mass number 1 and 8 are in the ratio of, so which one will be the correct option here? We know that relation between the radius of nucleus is and its mass number is given by r is equal to r naught, a to the power 1 by 3. R naught is constant here. So now you see, so that's why we can write there are two radii, so r1 a1 here, similarly r2 is equal to r naught a2 1 by 3. So the ratio of their mass number is given 1 and 8. Mass numbers are 1 and 8, so let's put a1 is equal to 1 and a2 is equal to 8. Then what we're gonna have, r1 by r2 is equal to r naught 1 to the power 1 by 3, and r naught a2 is replaced by 8 to the power 1 by 3. So r naught gone, so we have 1 by 8 whole to the power 1 by 3, and that's gonna be 1 by 2. So the required ratio is 1:2. That's a correct option is 1:2. That's the answer, right? So hope you have understood this. So how we have got this 1 by 2? So it's very simple calculation, because you know 1 by 2 whole cube is 1 by 8. So here we have whole to the power 1 by 3, right? So now let's move on to next question. What is the next question? So now here you see the average binding energy of nucleus of the order. So which one is correct here? So that should be option 3, 8 mega electron volt. That is the correct option. Now here, on emitting an alpha particle, a beta particle of mass number and atomic number of nucleus, this one changes to, so let me show you. Now you see during beta decay, alpha decay, okay, when alpha particle is emitted from a nucleus, suppose this is the nucleus, okay, here m is the mass number, n is the atomic number, suppose. So alpha particle is nothing but helium nucleus, He4, okay, here atomic number 2. So that means, so mass will be reduced by 4 and atomic number will be reduced by 2. So during alpha particle, this nucleus, mass number of this nucleus actually changes to m-4, okay, and during beta decay, the atomic number changes to, when beta decay takes place, what happens when, suppose you have a nucleus of mass m and atomic number n, then you're gonna get a daughter nuclei of same mass number, but here you're gonna get n+1, and we're gonna have E-1, right? This is the beta decay, and here this atomic number changes to n+1. So here which option is correct? So now you see, during if alpha particle is emitted, then let me show you again, just let me give you. Now here you see, this is the nucleus, mass m, atomic number n. Due to emission of alpha particle, okay, this should be reduced by 4 and this n should be reduced by 2, right? So that's why it should become this should become y. So it's supposed to be, let me write, x m minus 4 here, n minus 2. And when beta particle is released, then there will be no change in mass, but there should be increased in atomic number by 1. Okay, there must be an increase in atomic number by 1. That's why the daughter nucleus will be m minus 4 here, atomic number should be n minus 1. So the correct option is this. Okay, now because you see, let me show you again, let me explain it again. Now you see, so during beta this, suppose now from here, this is the nucleus. If alpha particle is emitted from this, then this should be changed to mass number this and atomic number this, right? And when beta particle is released, then it must be changed to here mass number m, that remains same, that n plus 1. Now here you see difference between this one and this one. You see, since due to beta particle there is this one is added, and due to release of alpha particle, 1 is subtracted from the nucleus. So 2 is subtracted from the nucleus, and due to beta emission 1 is added to the atomic number. And mass number, due to the emission of alpha particle, mass number is reduced by 4, but due to the emission of beta, there is no change in mass. So that's why our result is m minus 4 and n minus 2 plus 1, that means n minus 1. So this is the correct option. Option 2 is the correct option, right? Hope you have understood this. So now let me clean these things. Okay, now what is the next question here, D? What going to be the answer of this question? K-on is this. So this supposed to be this should be option 3. Okay, boson fermion, that is the correct option. Now let me answer this question 1E. So its correct answer is option 1, half n minus half. Okay, so now let's move on to the next question. What is the separation energy of nucleon? Okay, what is the separation energy of nucleon? Let me write the answer. So here is the answer to question number 2A. Okay, the separation energy is the minimum energy that must be supplied to remove the least tightly bound nucleon from the nucleus. Okay, now you see, suppose we have a particle X which is incident on a target particle. Okay, and particle small x is mass m, mass of the so I have considered that small x be incident on a nucleus capital X. Small mx is the mass of small x particle, and capital Mx is the mass of the nucleus. Okay, this is the mass of this nucleus and this is the mass of this particle. Okay, now you see this resulting nucleus is y of mass capital My, and particles small x, and also another particle is small y, and mass of this small y is small my. Okay, then the separation energy is given by this is the reaction that taken place that took place due to the incident of this small x on capital X, and then separation energy is given by this expression. Right, so this is all about separation energy for 2 marks. Okay, now let's answer to the next question. Next question is derive an expression for nuclear magnetic dipole moment. So let me give you the answer. I have already made a video on this topic. Just check the description box 2b. Then I have written 2b, question number 2b, and then I have provided the link. Okay, just click the link and you will get the answer. Okay, you're gonna get the video where I have explained this. Okay, now let's answer question number 3a. Okay, so here is the answer to 3a. This is 3a. Okay, so here is the first page, this is the first page, and this is the second page. Okay, this is the second page, this is page number 2. Okay, this is 1, this is 2, this is 3, and this is 4, right? So let me show you again, just give me a second. This is the first page, this is the second page, and this is third and fourth. Okay, pause the video and note it. So now let's move on to next question. What is the next question? Here you can see 3b, discuss the evidence of this. So this question was already asked in 2020 actually. In the paper 2022, not 2020, 2022, the question number 3c. Okay, this 3b was asked in 3c. I have already solved that paper. I hope you have watched that video. Okay, if not, then you're gonna get the playlist at the end of this video. Okay, that's gonna appear at any screen. Okay, and 3c, that was also asked in same year 2022. Okay, but in that year this was question number 3b. Okay, this was b. That means what they have done, what they have asked in 3c in 2020, this year they have asked in 3b, and what was asked in b, now it is asked in c. That's it. Okay, so hope you have understood this. Now let's move on to next question. Next question is question number 4a. Okay, so question number 4a, now let me answer this. So question number 4a answer, here is the answer 4a. This is the first page, take the screenshot, and this is the second page. Okay, that's it. So now let's move on to next question. Question number 4a, or let me answer to this question. So this is 4b or answer, 4b or, sorry, not 4b, 4a or, 4a or. So this is the first page. Okay, first page, and this is the second page, this is the third page, fourth page, fifth page. Okay, and here is the last page, sixth page. This is the last page. Now let me answer to the next question. So that is 4b. Okay, so let me answer to question number 4b. Answer to 4b starts from here. This is the first page, second page, here is the third page. Okay, that's it, first, second, third. Right, now let me answer to the next question. So 4c answer, pause the video, note it. Now let me answer to next question. Okay, so just wait. Now question number 5a. This question was asked in 2022 also, same question number 5a. Okay, in that paper as well. Then 5b, this was also asked in 2022, but it was question number 5c. Okay, 5c or, not only 5c, 5c or. Then so now let me write this resonance frequency. Sorry, not frequency. This is resonance reaction. What are resonance reaction? Let me write this answer. 5C. This is the answer to 5C. Okay, take the screenshot. Now 6A. So here we need to write short notes. So this was also given in 2022 paper. Okay, that was question number 6P. In that paper it was question number 6P. Now question number 6B, this was also asked in 2022 paper, but it was in 6C 2022 paper. Okay, so now this 6C, from this 6C I'm gonna answer this remaining questions in the next part. Okay, so thank you for watching. See you in the next video. Bye bye.